Hey, welcome students. It is Monday the 22nd of March. It is our last week of the third quarter, so we're going to try to finish out this week strong by continuing our introduction to quadratics and ending this week with some factoring skills. And so go ahead and take a look at slide 1. It's the do first. I want you to try each of these out following the pattern that you can see here, right? This top one's the multiplication of the two pieces in the corner, and the bottom is the addition of those two. So make sure you watch out for negatives. Come back after you try them out, hit play, and see how you did. All right, so hopefully you were able to pause this and try these out. This first one's pretty straightforward, right? You're going to multiply -4 times -7, and the negative times the negative is positive, so you get positive 28. Then you're going to subtract or add -4 plus -7, right? So that's going to give you -12. Hopefully you're able to find those. The second one's a little more theoretical, right? Or you have to think through this a little bit more. That -12 comes from two numbers that multiply to -12, and then 4 comes from those same two numbers that add. So I always like to just think of numbers that multiply to 12, right? We could have 12 times 1, 6 times 2, and 3 times 4 as whole numbers that would do that. Well, now, one of these has to be negative because our multiplication is negative, but the other one has to be positive because our sum is positive. So which one of these are 4 apart from each other? Oh, it's this one. And so I think 6 times 2 gives me 12. 6 plus 2 gives me 8. So how can I make that 4 and -12? Well, make negative 2 negative, so it's 6 times -2 gives me -12. And then 6 plus -2 gives me a positive 4. So this would be 6 and -2 makes that work. All right, try these other ones out that are a little bit more straightforward. Here we know our multiplication is -8 when we multiply 1/2 times something. So then we just undo that by dividing. So 8 divided by 1/2 gives us a -16. And so then when we add them together, -16 plus 1/2 gives us a -15 and 1/2. 1/2 and 1/5, when we multiply those, 2 times 5 is 10, right? And 1 times 1 is 1. So when we multiply two fractions, we often get a smaller fraction. And then 1/2 plus 1/5. Remember, if we add fractions, we need to have common denominators. So if we make the denominator 10, right, this becomes 5/10. And if this is 10, this becomes 2/10. So we have 5/10 plus 2/10 gives us 7/10. All right, walk back through those, check your answers, and let's move on to the next slide. All right, so we're going to review our squares, square roots, and the key quadratic vocabulary that we looked at last week. Go into your notes, make sure you have these in your notes so that our assessment next week, you can utilize this information. And so we're going to look at this review, the patterns in quadratic tables, and our vocabulary practice. So I want you to start by this. Drag the red point to change the size of the square and complete the table below. So if the side length of the square is 0 by 0, right, the area of the square is also 0. If the side length is 1 by 1, what's that area? 1 times 1 is 1. All right, and I want you to keep going through this. If the side length is 2, 2 times 2, look at how many squares there are. That's an area of 4. And keep on walking through this, and then we'll look at this finish by ourselves. So just keep dragging this to the side length and count the number of squares as it gets bigger and bigger. Or just use that idea of, do you notice what's happening as you multiply? All right. So here's the completed table, and you can see how it starts out slow. 1, 4, 9, but then the difference between those starts getting bigger and bigger and bigger. So this should be a review of how you square each of these numbers, but it comes with a great visualization of what that means in terms of the area. Here we go. I want you to answer these next few questions, and then come on back here and play it as we go through it. So pause, try each question out, so that you can see how your knowledge is doing. All right, you pause this, right? Good. And so it says the side length of a square with an area 100 is 10, and we call 10 that square root. Similarly, the square root of 25 is 5. So what's the square root of 81? So if you go back to here and we say, all right, which one had 81 squares? It was this one right here. And so 81 comes from 9 times 9. And so we say the square root of 81 is 9. 9 to the second power, right? So 9 squared. Let me see how I do this. 9 squared equals 81. So square root. So the square root of 81 equals 9. Now you can get that square root sign by clicking on this keyboard and it'll pop up and you can click square root. Or see how I have this programmed here? If you just type, you hit this piece right here and you hit backslash square, how's it go again? Looks like that. So if you hit this and you go backslash, where's that backslash? SQRT, and you get it. Well, actually, you just have to type SQRT, and then you can do that as well. All right? So there's two ways to do it, but the square root of 81 is 9. And see how those undo each other? All right, keep going. This is the square root symbol. So we say the square root of 16 is 4. The square root of 100 is 10. So drag the blue dots to place the value of each square root. All right, so go ahead, pause that, and come on back. So if you drag them, you would have gotten this sign that says perfect. And notice 225, the square root of 225 is 15, 144, 12, 81, 64, 25, and 1. So make sure you get those set up, and then join me on the next slide. So go ahead and fill in this missing table, pause it, come on back and see how you did. All right, so here's the filled out table. I bet you did great all the way up until this last one. 0.5, right? So what times what gives us 0.5, if I took the square root of that, right, I get 0.25. It feels like it's going the opposite way, but that's what's happening with our fractions. And then here, what times what is 0.16? 0.16 comes from this, when we take the square root of 0.16, we get 0.04. All right? All right, so now you got another one that you can match these all up. Notice the symbols that go along with the square roots and then the answer choice. So try those out. And if you look here on the next slide, we have some notes for you to take that will help you if you need any help. All right, so here's the finished card sort. Hopefully you're able to see that, the square root of 1, 4, 9, 16, 25, 36, square root of 49, and the square root of 64, what they equal. All right? So we have some notes for you to take. Make sure you have this understanding. If it's still a struggle for you, really write these down. If you feel pretty confident, you can move on to these next slides here. And so go ahead and read through this and then come on back. All right, so what did you notice about these quadratic tables? If you look at these 2 points that are our vertex, see as you go this way from the vertex or this way from the vertex, you get the same values, 7, 7, 4, 4, negative 1, negative 1. There's symmetry on either side of the vertex. Similar to this bottom one, negative 3, negative 4 is our vertex, and you can see we have negative 3, 0, 0, 5, 5. And so you get symmetry on the vertex. So if you can imagine graphing these, right, you have that vertex point, and then on either side it's either going to be the same, it's going to be the same output for what our input is, right? 2 and 4 give us the same output, 1 and 5 give us the same output, and 0 and 6 give us the same output. And so this is why there's symmetry on either side of the vertex. And so what are the roots or zeros of a quadratic table? So we talked about this last week. What does it mean to be a root? Okay, so think about that. What does it mean to be a root? What is the y-intercept? Okay, so when do we find the y-intercept? And what is the vertex? All right, so I want you to think through these three, put in your ordered pair answers, and come on back and see it in just a second. All right, so did you pause your way through this and try it out? I hope so. So remember, we get our roots when we have 0 as the output value. So when I plug in a 1, I get back a 0, and when I plug back a 5, I get back a 0. So 1, 0, and 5, 0, that's where it crosses the x-axis, our roots. All right. So what's the y-intercept? Well, just like our linear equations, when we find our x value is 0, whatever we get back for our function value, that's our y-intercept. That's where it crosses the y-axis. And so in this one, we can see when we plug in 0, we get back a 5. And so that's our y-intercept. And then finally, we're looking for that area of where the symmetry happens, right? So if you look at this point 3, -4, notice on either side of it we have symmetry, and so that is our vertex point at 3, -4. So make sure you have those written. Make sure you write down some thoughts about what it means to be a root, a y-intercept, and a vertex with this graph. So go ahead and label those in your notes. What's the roots, what's the vertex, and what's the y-intercept? Your turn to then fill in these missing values based on your knowledge of a quadratic table. So if you can find that symmetry, see what you can do here, okay? And so remember, find that symmetry, where's it happening, and how can you move forward from there, okay? All right, so hopefully you were able to find these check marks correct, but you should just guess and check, guess and check. And what you see here is 1, 0, 2, 0. That means my vertex is right here between those, and you can see the symmetry that starts. So double check your answers with this. And if you weren't able to find them, there's another example below that you can try out. So now that you have this completed chart, finding the vertex right here between the symmetry, 1.5 and 0.5, we're calling that the turning point too, right? So think about that. As it increases, it reaches that maximum and then it turns back down, or if it's facing up, it reaches the minimum, boom, that turning point or vertex, and then it goes back up. So make sure you have vertex and right next to it, turning point. All right, keep going down. We can see the zeros happen at 1, 0 and 2, 0, and then the y-intercept, when we plug in 0, we get back -4. All right, go ahead and try this one out. Again, look for that turning point, and it looks like it might be right here in the middle, so test it and see what happens. All right, and then fill those in. Do you do better on this one? All right, so hopefully you're able to see the symmetry showing up, right? -5 and 3 give us 36, and so as you work your way down, 36, 22, 12, 6, 4, and so then you can see, oh, our vertex happens at the point 1, -1, 4. Good. So then I am going to ask you, what are the roots? And I bet you're like, but Mr. Winter, there's no 0 values for f of x. Exactly. Remember, sometimes our quadratic is above the x-axis or below the x-axis, and there are no roots. So you're right, there are no roots for this function, which also means there's no real solutions. All right, and we'll talk more about no real solutions moving forward. Then finally, when I plug in 0, I get back 6, so that's my y-intercept. All right, watch this, love it, live it. Good. All right, you now have 10 practice questions that I want you to walk through. Make sure you're reading them and talking about how many solutions they have as you walk forward. All right, come on back for a quick check at the end. All right, hopefully you made your way through all 10 of these practice questions. A lot of them gave you feedback if you got them correct or not. Make sure in the reflection on slide 27 you tell me which things you're still struggling with in today's class. And so if you walk through here, this is not crossing the y-axis or the x-axis, so we say it has no solutions, no roots. All right. Practice 2, those roots are -4 and 6. Practice 3, you drag them, you get the correct answer where those roots appear. Same thing with 4 and 5. Double check, move them until you get the correct answer. This axis of symmetry is the whole line, but if you drag it up here, it's when you get it correct. Okay, so if you drag it anywhere other than that spot right there, it is the whole thing is the axis of symmetry. And then finally, your left 0, right 0, and your minimum, it would only be a maximum if it was flipping the other way. Nope, try again. All right, remember, maximum is when it opens down. All right, and so as you walk through these, you should be able to find the x equals equation for symmetry in line 6 and line 7. And then finally here, label each of these points, the axis of symmetry, the roots, the y-intercepts, the vertex. And this vertex happens to be a minimum. And then plugging in or finding the numbers for each of these, the order pair is -2, 0, 0, 0. It happens to be the same as the y-intercept, right? It's crossing through the origin. So that y-intercept's also 0, 0. The ordered pair of the vertex, over -1, down -3. All right, and then finally, remember our equation for the line of symmetry is always equal to our vertex's x value. All right, so you're going to get to do this next one on your own. And then when you finish that up, go to the homework on slide 28. All right, I hope you enjoyed this, and I hope you're learning and able to crush quadratics. Have a good day.